Hello, I'm Anna Mackay and this video is on definite integrals. So we've already looked at how to apply the rules to integrate functions, but now we're going to have a look at what to do when we want to know the area under a curve between 2 points. So here's the definition, and the explanation of that is if capital F of x is the antiderivative of f of x, remembering that if you have f of x and you differentiate, you're going to get the derivative, so this is going backwards, where f of x is continuous on an interval a to b, with b being greater than a, then the definite integral of f of x, so here's the notation here, on this interval is capital F of b take capital F of a. So what we have is you integrate, apply the rules, and then you substitute in each of the numbers, b and a, with b being greater, and subtract them. So let's put that into practice. But first of all, here are some of the properties of definite integrals. So this one here, if a definite integral between b and a is this, then it's actually exactly the same as the negative with b and a switched. That'll come in very handy a bit later on. This property here, if you have k multiplied by a function where k is any constant, you can move k out the front of the integral and then integrate and bring it back in later. This one here, that the integral between a and c can be split. Notice that the b is at the top here and b is at the bottom there. One way I like to think of that is, imagine those marble popping games where you get two letters next to each other and then they hit and disappear. Imagine it like that. So those b's essentially disappear and it's the same integral, but it helps you to split it up to do it in two different sections. Again, this will be more use in the next chapter. And this one here allows you to split the integral to be for term by term. So the integral for that part of the function for a and b, add on that part of a g of x function is the same had it all been together. All right. Some examples. Finding this integral here. So as we know, you take each term, raise the power by 1 and put it on the power. So what we have here is we actually use square brackets for this part, raise the power by 1 and put it over the power, that's a 3. Take away the next part, raise the power by 1 and put it over that new power. Notice that those 2's will cancel out. If you knew that straight away, it's fine for you to go straight to that step. And then this one here, well, what power of x is that now? Technically it's to the power of 0. So raising 0 makes it x to the power of 1. So we're just going to write x. We could put it over 1, but we don't need to. Close the brackets and we put the 3 there and the 1 there. Now you might be asking yourself, well, what about that plus c? Well, what is going to happen, I'll just write this off to the side here, no need for plus c, is that with those square brackets, we are now going to substitute in 3 into each term and take away when we substitute in 1. So what would happen is we would get plus 3 plus c, and then take away, should probably use round brackets there, where we plus 1 take and plus c, and as you can see, you're going to get c take away c, and they're just going to cancel out. So we never have to put in the plus c when we are doing definite integrals. So let's carry on with our question here. We now use round brackets when we're substituting in the numbers. So we have 3 to the power of 3 over 3, subtract 3 squared plus 3, close bracket, subtract, round bracket. Please use the brackets here. It's going to be particularly useful when you get negative numbers in the future. So we've got 1 to the power of 3 on 3, take 1 squared plus 1. You don't have to show all those steps if you're fine with that. And let's see what's going to cancel out here. So I'll write out some of these. Up here, well, that 1 squared is 1, so that's negative 1, add 1, they're going to cancel out. So we're left with here, take a third, and that comes out to 8 on 3. So that's your answer for the definite integral of that question. Moving on now, a trig question. Okay, so the technique is think about what is the integral of cos x, that is sine of x. So it's equal to sine of x, you don't need plus c, square brackets, and you put your two numbers, the top and bottom right corners right hand side. Now equals round brackets, substitute each of those in. So pi on 2, take away sine of pi on 3. Now, what are each of those equal to? So you've got to be able to remember your unit circles. So we've got unit circle here with 0 and pi over here. So pi on 2 is at the top, so that's 90 degrees. Sine represents the y coordinate. So the y coordinate at 90 degrees will be 1. Take away sine of pi on 3. So if this is pi, dividing that up into 3 sections, if you like. So pi on 3, so we want 1/3 of that. Now remember, one of these will be half, and one of them will be root 3 on 2. Perhaps I haven't drawn that particularly well, but the x coordinate will be half and the y coordinate will be the root 3 on 2. So you can leave it like that by all means. I'm just going to put the decimal answer because now we're going to go check this on our calculators so you know if you've got the right answer or not. So have your calculators handy. And here we are. So the instructions I've got here are how to do it in 2 ways. First of all, in the run mode. So menu 1. So if we push F4 for math, arrow across F6, F1, that integral. So we need to fill out here that we're working out cos of x, arrow across gives you the lower number, and we want pi on 3 it was. Shift pi on 3, arrow now gives you the top one, and we want pi on 2 here. Enter 0.134. That's the number that we've got. So always check these in your run mode. I'll show you on graph as well while we're here. Here are the instructions for graph. Oops. Okay, so cos of x, making sure we have a trig window, but I'm just going to narrow that down a little bit. Draw that. Okay, so here are the instructions. We're going to G-solve, arrow across, F3 is this integral, now F1 is the integral, and look at the instruction, select lower limit value. So the lower one was pi on 3, enter, execute, and now select upper limit value. Shift pi on 2 or divided by 2, enter, and here's what we've been working out. The area under the curve between those 2 points, and have a look here, the integral is 0.134. Excellent, that's what we've found. One more example that we've got to do. Bear with me. Okay, so what if you're asked to find the integral and that the area, the answer, is 9? But you don't know between what values. So we have to work out k. So one step at a time. Apply the rules. It's quite similar to the first one that we started with. Raise the power by 1, put it over the power. Same here, those raise the power by 1, put it over the power, and those 2's are going to cancel out, and that will be 3x, square brackets, k and a 0 equals 9. Okay, so now we're going to substitute in k. Now here we don't need another equals, but if you have that need to put something at the beginning, put a therefore sign. Substituting k, k cubed over 3, take away k squared plus 3k, and subbing in 0 to each of these. Conveniently, they're all going to be 0. Sometimes that happens, and that's very handy, is equal to 9. So we have to solve for k here. So I'm going to tidy this up a little. I'm going to multiply everything through by 3, and I'm going to bring that 9 over to the other side of the equals. So I've got k cubed, take k squared, but multiply that by 3, plus 9k, that'll be equal to 0. 9 times by 3 is 27, and it will be subtract 27 because let's jump the equals. How do we solve for k? Use your graphics calculator. So back onto that one. I'm just going to tell you right now though that the answer is 3, and check it on your graphics calculators. Here we go. So the menu for that is equation. So menu A, we want polynomial. Written over here is the equation. You need to put in the coefficients. So we have 1, -3, 9 and 27. Execute that and k is 3, just as we anticipated. So that's the end of this video. If you liked it, give it a thumbs up and subscribe to the series, and the next video will be called Discovering Integrals. Thank you.